How's it going, everyone? Welcome, Elier Gonzalez here. Today, let's going to now explore of the scope system. I'm gonna make a quick recap of how do we get here. This is a course taught by Kyle Simpsons, software engineer that has previously worked at several companies, and now he's the author of a series of books like You Don't Know GS, very compelling name, and the other is the functional light JavaScript. To those, right now we're looking at this first section or this first series of book that You Don't Know JavaScript. We already look at um, the functional like JavaScript, and I think I shouldn't have saw that before, but at least it gives me now what are the paradigms that we can apply and that what React is applying to, as well as other frameworks, when it comes to provide their solution, whether it's to build user interface or allow them to create now a reactivity system like Vue, or in Angular to understand now this entire web frameworks and all the different patterns that they're using. So, since this course is now describing is the three pillars of JavaScript that we must be competent as a way to route, read, and add or remove features, and when it comes to add bugs or yeah, but remove bugs is to we need to be competent of this. We need to understand what this language is doing behind the scenes in the most succinct, precise way possible. So anytime that we encounter a particular scenario, we know what is doing, what will happen, and therefore we can now move on to the next topic. So we can focus our attention on what's matter, which is developing the business logic. So we already know what is doing behind the scenes. So the language is less dangerous, or we are less dangerous, because we have now this certainty, and we can now write code that we understood, that we and that somebody else wrote, so we cannot understand the intention. So because of this, so this code is made of three pillars, and in the first pillar we have the type system. The second is the scope system, which is what we're gonna look at today's video. And the third is the objects oriented. So the first talk about is the type systems. Any programming language that you're gonna work with has to deal with this type of systems. And since we first look at the primitive, what is the primitive? What is the way of defining or to get is a type of this primitive using the type of operators, and how we look at some edge cases like null, for example, and also like null, for examples, and why we have is 0.2, 0.1, and 0.3 give us is now 0.3, 0.000000004, all right? And this is because now the representation of those numbers are not accurate. 0.1, 0.2, they are not accurate in binary or in bit floating operations, bit floating points. So they have to round that number, and by doing that, of course, you lose precision. We have to round it because our memory is limited, so we cannot represent that number. This is similar to in the decimal, which is more descriptive. When you try to divide 1 by 3, it won't give you now a fixed number like 1 by 4, which gives you now 0.25. So if you divide that, it gives you now 0.3, 1 by 3, it gives you now 0 0.3, 0.3, 0.3, 0.3, 0.3, 0.3, and at some point you need to cut that around that number and to say, well, I need to fix that, I need to store this representation somehow on the memory. And since the IEEE, the Institute of Electrical Engineering, the Institute of Electrical and Electronic Engineers come up with a spec or a standard known as the 754 of how we're going to organize our numbers, how we represent numbers, and what is the maximum length that we can represent in a safe way up to 15 digits. We can represent maximum is 70 digit, but because the representation that we are using, or that the engineer, the electrical and electronic engineer are using, sometimes they're gonna lose precision. That's why they say that if you go beyond the 15 digits, it's not guaranteed that that number is accurate. In other words, we cannot store that particular number or do some operation with those numbers and give you now an accurate representation because our memory is limited. So this is a good segue to starting to understand now this is hardware problems or hardware limitations. So in other words, this is good enough because it can represent is very long numbers. However, because of that, we have now this big int. And the big int is when you need to represent is huge numbers. For example, galactic distance or astronomical events or finance or even cryptography. So we can use big int for that. There are also some special values such as positive and negative numbers, as well as the NAND, and how now this positive and negative value we can use them for directions. Also the NAND to tell us, hey, this is not a representation of a number. No, it's not a valid representation using the spec 754. And NAND, unlike any other primitive, all right, is not unique to itself. And this is called part of the identity. And with this identity, which is the way of how you can, this is for a more mathematical concept, but the identity is something that JavaScript use as a way to determine is that is itself. That is something that can be used or can be identified uniquely and unchangeable to itself. So NAND is one of the primitives that cannot be used to that. So for example, if you want to use now triple equals or double equals to that, of course, it won't give you now, it will give you false. The other concept of idea is the idea between the undefined, undeclared, and uninitialized here. So, why are we doing this? Or what are the different stuff here? So, undefined at the end of the day is something that you define, but you haven't assigned any value to it. All right. And the other is undeclared, is that you didn't even create that or declare that. And the other is the uninitialized, which is used for block scope variables. When you have now this temporal depth sum, when you declare that, but you didn't assign any value to that, and the value is not assigned by default to undefined. So for example, what happened with var. So we also look at this, how you can get the type of this value, and when you can use this type, and the abstract operations, or the most common abstract operation, getting ourselves familiar with this type of abstract operations, such as the primitive, string, number, and booleans, as well as the equality. Why this is important, you might wonder. Well, because this slowly but progressively opens up our mind of what are the things that we need to look or focus in, starting to understand this spec, which is organized in this numeric algorithm way. And I think that's powerful, and I think that's something worthwhile to look at it. Because anytime that you the abstract operation, anytime that you want to understand the behavior or this abstract operation, which is something that JavaScript doesn't expose, is a behavior, is an algorithm that is conceptual that JavaScript does. So you can look at that and understand its behavior. So for example, is the plus plus operator, or the plus operator, or the negate operator. And what happened, for example, when JavaScript is starting to coerce or convert from one type to another. And I think this is one of the powerful stuff of JavaScript, since the barrier entry is so low that anybody can get in here. But as you move on in this language and developing and building applications like that and so on and so forth, you're starting to develop an intuition of how things works, and why things works is not clear to you. So looking now at the spec is something way much more useful for you, so you can know where all of this come from. Too primitive, at the end of the day, what it's doing is to coerce whatever value that you're passing into one of these primitives, and also passing a hint to that. So whether it's a string operation or a number, it's going to evaluate is, in the case of a string, the to string, and if it doesn't produce any of this string, then it's going to now evaluate as a number, and vice versa with the to number. So if we pass, for example, now an object, most of the time, or it's likely, that is going to coerce that into a string. All right. So, but again, the hint is something that is going to be evaluated by JavaScript. The other is a toString, so the stringifications of primitive. We also look at that. There is some corner case with positive and negative values. The other is the stringifications of numbers, of what's going on. So for example, negative numbers or negative 0 is not going to coerce that. So numbers is gonna coerce properly, except for negative zeros. And the other is the objects or arrays. And more interesting is array, because all of these corner cases. So an empty array is gonna transform into an empty string. A number of arrays, or an array with numbers, you're gonna coerce that into all of its value in a comma separate value. Null and undefined is gonna give you now nothing. And if you pass, for example, now empty arrays inside of that, it will give you now all of these comma separate values. So the pattern here is that it's gonna give you values in a comma separate way if there are numbers or strings, right? In the case of the array. And in the object, it's gonna give you now is the object, as we are quite familiar with. So then we look now at the toNumber. So these numberifications of string, or these numberifications of values. So first we look at the string. So when we pass now in a string, how that it converts, as long as the string is a number, it's gonna convert that properly. But except when you pass now an empty string, which is gonna convert that into 0. Okay? And we're gonna see that why this is something that can be problematic. The other is the non-verification of Boolean, pretty straightforward. True and false, 1 to 0. Null is 0, and undefined is none. The other is for objects. How is the non-verification of this? For example, of an object, is going to coerce that. That's interesting. Into not a number. All right. So that makes a lot of sense. But when it comes to an array, things started to get quite interesting, because an empty array gives you 0. An array with 0 will give you 0. An array with -0 will give you -0. An array of null or undefined will give you 0. Okay. If you say this or this, if you have more values in that array, you try to coerce that, it will say no. And the other is the undefined. So unlike primitive, where it coerces now into undefined to none and null to 0, this is one of the corner cases of this non-verifications of arrays. Okay, and the other is for object. And a Boolean is more straightforward. It's just a lookup table of falsy value. If any of these values are not false, whether it is a negative, a positive 0, none, empty string, false, or undefined and null, all right, all of them become 0 or falsy values. Anything else is a true value. So why are we looking at this? Is once we started to understand now the spec and what this is doing, what this algorithm is behind the scenes, we also recognize is what are some kind of operations like additions is preferred to. Okay? So for example, the addition operators will prefer string concatenations and then numeric numeric coercion. So the point of this is that if you need to indicate, so the point of this is to be intentional with that. Okay, intentional with the type that you are going to coerce. So there's some other corner cases, right? So for example, with numbers, that when you are going to pass an array of null or undefined, it gives you now 0, and if you pass now null, it gives you 0, and if you pass undefined, it gives you none. You know, all of this queer behaviors. But the point of this is to be descriptive about the type that you want to coerce, and also sometimes let now the be implicit about, or use the implicity of this, because you can also get benefit from that. The idea is to understand that when to be explicit and implicit is important, at least when you're going to describe your code. So for example, boxing, which is another abstract operations that allow you to now have access to property. So JavaScript temporarily wrap an object when you're trying to access its property, so you can access to. All right, this is known as boxing, and this particular property is something that is good because now you can get the benefits of this abstract operation, this implicit operation. The TLDR of all of this is that be intentional about the code that you're going to write, the type that you're going to use, also that you need to improve, or that you need to dive into the language and how this language works, because this is part of the way of how you can get better and avoid any most common gotchas and problems, right? So make your life easy from the future. That's the reason why actually I'm doing all of this, because I'm generally going to dedicate time to this. All right. And when it comes, and remember that by being by being by being intentional about the code, you are in your code describing what it does or how it does with your plain code, and also with the comment, which is something that we're not going to see that a lot of the time, because a lot of people actually rely heavily on TypeScript, and how this static analysis is something that is going to help us here. Don't get me wrong, TypeScript is something that, of course, is needed in the language, especially for big applications when a lot of things are happening. So you want to have now this kind of certainty that that you can see now is the data flow in your application. I get it. As well as to understand the the intention about the code much more straightforward, and some of the benefit that we can get at compilation phase, right? Instead of the runtime. So for example, some runtimes errors won't happen, all right? It will happen only at compilation phase. So that is great if you have now a huge applications that has a scale to a lot of applications, a lot of developers, and that application now knows all of that application cover some corner cases like this, like the coercion of the type, and so on and so forth. Now, with that, okay, then we look now at the equality abstract operations, okay, or this testing and comparison objects in the abstract operations, especially the double equal and the triple equal, where now by exploring at the algorithm of the double equal, if they are the same type, I'm gonna pass through the triple equal. If this is now an undefined or null, any of these parameters are undefined or null or swapping position, okay, then I'm going to treat them as true, okay. However, if one of them is a string and the another is a number, or vice versa, then I'm gonna do a numeric coercion. However, if the values are Boolean, and this is something that I want to take a look at this. Oh, this is not, this is the sec identity here. You got it. Exactly. This one. So, however, if one of them is a big int and the other is a string, I will prefer to do is so if the first is a big int, so if the first is a big int and the other is a string, I will prefer to do now a coercion here, a string coercion. However, if they are swap, if the first is a string and the other is now a big int as well, all right. So in both cases, it's doing this coercion, this string coercion. However, if one of them is a boolean, okay, I want exact. If one of them is a boolean, I will coerce that into a number as well. And if one of them is an object and the other is a primitive, or vice versa, I will try to coerce that object into a primitive. So for example, if you have this and somehow you do this, so true for example, what will you think that is the value here? Here we're saying that is of course false, but what would you think that this will be the value here? All right, what would you think that this will be the value? So because here it's going to be transformed, so since this is a number, so since this is a number in this case and the other is an object, it's going to do now a numeric coercion here, or a primitive coercion, that when you transform this into a string, okay, through the toPrimitive method, it will give you now an empty string, okay? And if we have now an empty string and a number, right, it will coerce that into a number. Therefore, this stringification of empty string is now a 0. Therefore, now it becomes true. So this is just a couple examples here, or more quick examples are like this. And here we can see that and explain that. I'm not gonna dive deep too much into that. Just wants to point that out when that will happen, and that at the end of the day, the idea of understanding now this double equality, triple equality, and the object.is is that we can look now at where this algorithm come from, the abstract operation are coming from, so we can now understand its behaviors. It becomes now predictables, and therefore we can choose is when to use now the double equal, for example, right? And the TLDR is that if you got, most of the time we're not going to use the double equal. A lot of people are going to use the triple equal. But the thing here is that with the double equal, you are now for sure, whoever is using that is to indicate the intention of the code to say, hey, we want you to have this definition of this equality assign, or this equality evaluation, right, as to be known as the type. So the TLDR of that is that you have to be sure about what is the type of values that you are comparing to. So for example, if both of them are objects, which is something that this algorithm doesn't describe here, all right? So if both of them are objects, now it becomes false. There are some more reasoning about that, because at the end of the day, all objects now have their identity, okay? So objects are considered identity like this. So for example, records like this, example of specification values without a specification identity, okay? Include records, property descriptor, and parsing, and so on and so forth. But the identity here is values with identity are likely values without identity, but without additional unguessable, unchangeable, universally unique characteristic called identity. So a value without identity is never equal to a value with identity. So this is part of the definition here. A value without identity is never equal to a value with identity. So value without identity example of a specification value with specification identity, okay, which means is that they are unique, okay, they are universally unique, unchangeable, and unguessable, called identity. So, in other words, somehow you have now those type of values like objects or records, okay, something that they find here now pointing or storing or referencing into different space in memory, right? Into unique places. So after we went through that particular example, so now it makes a lot of sense. All right. No. Exactly. This is why this gives you now true, and this is now what gives you now false. Right? This you now give you true, and this now will give you false. All right. We also mentioned about the benefit of static typings, and now the scope of this, man. The scope of this. So, the scope system, which is another pillar of the JavaScript, is something that we're going to look, especially the lexical scope, as a way to look at the lexical scope to understand now. So lexical scope, or the goal of this particular pattern or this particular pillar, is to see how can we organize our code in a much more effective way. So improve our code organization. So to do that, we need to look at the lexical scope, and then to understand, that improve our code organization. And to do that, we need to understand lexical scope so we can understand closures, so we can now understand is the model pattern. Okay, so we can understand the model pattern. Makes a lot of sense. Okay, let's get into this.
We can understand the module pattern. So that is our goal for this unit of discussion. Let's dive in. All right, scope is where we look for things. That's your first what you need to know definition on this topic. It's where to look for things, but that definition should ask a couple of questions in your mind. Number one, what is it that we are looking for? So very simply, we're looking for...
Scope is where are we looking for? So scope what are we looking for, right? Is where to look for things. The scope is where to look for things.
Identifiers. Here you see an X that's being assigned to, or a Y that's being a value retrieved from. Whether you realize this or not, all variables are in one of those two roles in your program. All variables are either receiving the assignment of some value, or you are retrieving a value from the variable. That's it. There's no other existence for variables in our programs than that.
So all variables exist in our program only to receive a value or assign a value
of some value, or you are retrieving a value.
Exactly. You're receiving a value
from one of those two roles in your program. All variables are either receiving the assignment.
Exactly. It's receiving the assignment
of some value, or you are retrieving a value from the variable. That's it. There's no other.
Exactly. So you are receiving the assignment to a variable, You are reserving space in memory for a variable, or you are reading the variable, or you're accessing that variable.
Program. All variables are either receiving the assignment of some value, or you are retrieving a value from the variable. That's it. There's no other existence for variables in our programs.
From the variable.
So what we're doing is we're fundamentally, when we're processing our code, when the scope is being processed by the JavaScript engine, it's essentially asking the question, when I see this variable, first of all, what position is it in? And secondly, what scope does it belong to? In other words...
So when JavaScript is analyzing our code, at first,
JavaScript engine, it's essentially asking the question, when I see this variable, first of all, what position is it in?
Okay, so when JavaScript is analyzing our code, variable is asking this question. So it is position. Interesting.
And secondly, what scope does it belong to?
It is position.
In other words, this is basically like a game of matching marbles to their color-coded buckets. If you think about the way a JavaScript engine processes the code, it's going to find a variable, and it's going to say, this is a green marble, so it goes in the green bucket. And this is a red marble, so it goes into the red bucket. This is fundamentally a game of sorting colored marbles. This was the best picture I could find on Google. I could either find colored buckets, or I could find colored marbles. I couldn't find them together, so here you go, colored buckets, okay? All right, but there's something nuanced about that definition that may not be all that obvious, which is that this processing that we're talking about is an actual step within JavaScript. It's not simply inlined with the execution. It's extremely common for people to think about JavaScript as running top-down, line by line executing, because when we think of interpreted programs or dynamic scripted programs, we generally think of them as executing line by line, top-down. And so when I assert to you that JavaScript is not an interpreted language, but is in fact actually a compiled language, that may not fit with your whole mental model, because you're probably used to thinking of line by line JavaScript interpretation. So let me prove to you that JavaScript is in fact compiled, or at least as we would say, it's parsed.
Okay, so there is a misconception about JavaScript that runs line by line our code, where in reality it is a two-phase where in reality it's a two-phase process. The compilation or parsing, and then the execution.
But there's some processing step that has to happen before execution has occurred. If you have ever written a JavaScript syntax error, left off a comma, had an extra parenthesis or curly brace somewhere, and then you tried to run the program and you immediately got ever written a JavaScript syntax error, left off a comma, had an extra parenthesis or curly brace somewhere, and then you tried to run the program and you immediately got a syntax error. That is, say you have a syntax error on line 10, but you immediately get that error reported to you before lines 1 through 9 have executed. You may never have stopped to ask, but syntax error of a comma, had an extra parenthesis or curly brace somewhere, and then you tried to run the program and you immediately got a syntax error. That is, say you have a syntax error on line 10, but you immediately get that error reported to you before lines 1 through 9 have executed. You may never have stopped to ask.
So for example, if you make a good example of that, exactly. So for example, if we make a complex example of that, to say let object is equal to this, and then you're gonna do this kind of operation. Say object dot value 1, say 1, and then you do is something like this. So for example, you add now an extra parenthesis here and say object 2, object value 2, and say now, hey, I want to be this is a function here. All right, and if you do something like this, okay. Exactly. So some syntax error, for example, like this. So for example, you get this. You're gonna say let user exactly. So user object.name, and here you say is now point, and you pass something like this. So it will give you now is a syntax error. It will give you now a syntax error here. So it's now this compilation phase that's happening here. It's this compilation phase that is happening here. It's a compilation phase. And you're gonna get is this. Uncaught syntax missing formal parameters.
But the question bears asking, how is it possible that JavaScript knew about the syntax error on line 10 before executing lines 1 through 9, unless JavaScript actually went through a processing step first, as opposed to simply executing top-down? There was some processing step. So what does that processing step look like? Well, I'm an old compiler theory nerd from my computer science days. I am one of those weird folks that writes compilers for fun. I enjoy doing that sort of stuff. And so in compiler theory, there are essentially 4 stages to a compiler. Sometimes the first 2 are combined into one stage, sometimes they're separate. My textbook had them separate. So there's Lexical and tokenization, there's parsing, which turns...
Exactly. So here, so there might be a process that happens before our code is executed. So this process is parsing, which in the context of JavaScript, okay, which is on the creation phase, on the syntax directs operation, like this, is the syntax operations here. So if you ask Claude about this, is the syntax directed operation, is a syntax directed operations in ECMA ECMAScript. Exactly. It's a syntax arithmetic operation in ECMAScript indicating what happened at the creation phase that's more a conceptual model we use to understand JavaScript execution associated with grammar productions that define how process different syntax construct. They specify the step-by-step semantic for operation evaluations, declarations, static semantic analysis, and what you might be thinking as a creation phase relate to a specific SDO like global declaration instantiation and function declaration instantiation. Okay, the syntax direct operation. Various create abstract operations. The spec doesn't explicitly divide execution into creation and execution phase like some educational material do. Instead, it defines the precise algorithm step through SDO. The conceptual creation emerges from the operation that happens before evaluation. SDO run, particularly the declaration instantiation process that set up the lexical environment with undefined binding for var and initializations. So SEO defines the mechanism while the creation phase is our mental model for understanding when certain setup operations occur relative to code evaluation.
Turns the stream of tokens into this, what's called an abstract syntax tree. And then the last step is what's called code generation, taking an abstract syntax tree and producing some kind of other executable form of that program. That's basically, in 57 words, a computer science degree for you, right? That's, or at least compiler theory for you, right? Like that is how a program gets processed from its textual code in your source format into some kind of representation that can be executed. Now, a lot of people think, well, JavaScript can't be compiled because I don't run a compiler on my development machine and then ship off the compiled code to some other location. So in other words, a lot of people think about this difference between interpreted and compiled as the distribution model for the binary. But that's not really the right axis to be thinking about. The right axis is the code processed before it is executed or not? We do have languages that exist which generally don't get processing before execution. For example, bash script. In a bash script, if you write a malformed command on line 4, lines 1, 2, and 3 are going to run, and when line 4 fails, that might screw stuff up because you want to undo lines 1, 2, and 3. This is a perpetual problem in something like a true scripting language. But in JavaScript, if you have a syntax error on line 10, nothing happens on lines 1 through 9. It has to be processed to check that it's a well-formed, correctly formed program. So this is going through these compilation steps, and the reason I bring up this compiler theory to talk to you about JavaScript being a compiled language is because we need to think about when all this marble bucket sorting happens. If you think about this marble bucket sorting stuff is happening at runtime, it turns out that not only is that an inaccurate mental model, but it turns out it can create bugs within your program because you assume something to be true and something is different. That divergence, remember the Gettify's law? This is a divergence where you think something and the computer thinks something else, and guess who wins? The computer, okay? So what we want to do is try to align our brains more like the computer. We want to think like a compiler. The good news is that even though we're going to talk a little bit about compiler theory, there's a whole bunch of it that we're going to completely gloss over. A bunch of complexity that is not important for this discussion. But the one thing that is important is our marble sorting. Marble sorting is the thing. It is essentially that metaphorically is processing of our scopes and putting all of these identifiers, that is the colored marbles, into their correct buckets. So the way that processing first happens before we execute is that there's a stage where it goes through all of that compilation, it goes through all of that parsing, and it produces this abstract syntax tree, but it also produces, essentially, a plan for the lexical environment. That is, where all the lexical scopes are, and what marbles are going to be in them, what identifiers. It prepares this plan, and that is the executable code that is handed off to be executed by the other part of the JavaScript engine, okay? Now, some people would say, for example, Java, well, that's a compiled language because I compile it, and then I distribute a bytecode. It turns out JavaScript does almost the same thing. Java execute environment. That is, where all the lexical scopes are, and what marbles are going to be abstract syntax tree, but it also produces is that there's a stage where it goes through all of that compilation, it goes through all of that parsing, and it produces this abstract syntax tree, but it also produces, essentially, a plan for the lexical environment. That is, where all the lexical scopes are, and what marbles are going to be in them, what identifiers. It prepares this plan, and that is the executable code that is handed off to be executed by and what marbles this abstract syntax tree, but it also produces
initially produce the abstract syntax tree. Okay. the abstract syntax, the abstract syntax tree. Okay. And the roadmap
essentially a plan for the lexical environment. That is where all the lexical scopes.
and a roadmap or a plan for the lexical environment. And then execute the code. Execution context creation, declaration instantiation. This is closer to what we're calling creation phase. Declaration instantiation and co-evaluation. Parse, create execution context. Okay. It parse the generate the abstract syntax tree plus the static analysis it create the execution context the lexical environment setup, your creation phase. Create execution context, the lexical environment setup, your creation phase, and then execute, evaluate expression and statements. The plan for the lexical environment. And the lexical environment setup. And then the execution. This sequence repeat for different execution contexts. But first,
are and what marbles are going to be in them, what identifiers. It prepares this plan, and that is the executable code that is handed off to be executed by the other part of the JavaScript engine. Okay. Now, some people would say, for example, Java, well, that's a compiled language because I compile it and then I distribute a bytecode. It turns out JavaScript does almost the same thing. There's a parser that parses through your JavaScript source code, and it produces, in essence, an intermediate representation not that dissimilar from a bytecode, and it hands it off to the JavaScript virtual machine, which is embedded inside of the same JavaScript engine. And it interprets all of that stuff, and one of the things it interprets is whenever it enters a scope, it creates all the marbles.
So whatever you enter in scope, exactly. So whatever you enter in scope, so So JavaScript first parse our code. JavaScript first parse our code. Then whenever it enter
embedded inside of the same JavaScript engine. And it interprets all of that stuff. And one of the things it interprets is whenever it enters a scope, it creates all the marbles.
So JavaScript first parse our code, and during execution it create the execution context anytime it sees one. Parse 1 create the execution context as needed during execution. Parse all of the code upfront, build the AST, and doing static analysis, and then execution context create on demand. So during the execution, whenever the engine encounters something that needs its own execution context, global code, function calls, eval, etc., it creates a new execution context with its own lexical value. This capture. So these direct syntax operations are not describing that. JavaScript doesn't create execution. It sees one during execution. The process is more structured. Parsing and execution, then it begins the execution context creation. Global execution, predictable moments. Global execution, function execution, and then with eval here. Parsing versus execution. So JavaScript first create the code and then begin the execution. So JavaScript first parse the code to check for syntax errors and build the abstract syntax tree. Then it begins the execution. And during this execution, it creates at a specific predictable moment the global execution at first, the global execution context first. Once the script start running, so once the script start running, the function execution, anytime that it evaluates this function execution context, okay, function execution context, okay, function execution context. Create each time a function is called, exactly, create each time a function is called, not when it is defined or seen, exactly, not when it is defined or seen, not when it is defined or seen, and the other is eval execution context, but it's rarely used, you know. And eval execution. Rarely use. But I want to know what happened. But what happened during the parsing? No execution contexts are created during parsing. Only happen when execution begins. So this is syntax analysis, hoisting preparations, and scope analysis. So JavaScript first parse the code to check for syntax error and build the abstract syntax tree. So during this phase, okay, JavaScript parse the code, exactly. So JavaScript first parse the code. So during this phase, it now builds an abstract C. Okay, it checks for errors. It checks for syntax error. Okay, it checks for syntax error. Builds the abstract syntax tree. And then identify tokens. It makes sense. So I then identify tokens. This is the syntax analysis. This is the syntax analysis. This is the syntax analysis, and then you have now the hoisting preparation. When you have now functions, the entire function is stored in memory. Functions are stored in memory. Variables are variables are initialized with undefined, and let and cons are hosted but placed in a temporal depth zone. And then is when the wait a moment, bro. And then when is the scopes analysis happen? Scope analysis. So determine which variables determines which variables belongs to which scope, create lexical environments, and then identify closures, relationships. So determine which variables belong to which scope, or in this case, which identifier, or variable This precise description to me is quite important because that's the essence of this. That's the essence of this. Between parsing and execution phase well. Let me add some nuances. Parsing refinements. Your hosting description is more accurate, but there is a subtle distinction. Let and cons are technically hosted. Their bindings are created, but they remain uninitialized in the temporal zone rather than being initialized with undefined binding. They didn't say that. Oh. Are hosted, but placing are hosted. Exactly. Variables var are initialized with that. Syntax analysis. The parser also performs semantic analysis to catch early errors like duplicated parameters named in a strict mode. Okay. In semantic error. And then semantic errors. And exactly, and check for semantic errors. Same variable redeclare, or variables redeclare. Okay, I know I'm doing this. It can be quite boring for you to look, but this is particularly refinement process that I'm doing here. This is a solid breakdown of JavaScript parsing execution. And you have captured the key concept well. Let me add a few clarifications. Actually happening in this stage, lexical analysis to codification comes first, then parsing build. Okay. Semantic error like variable declaration are often caught during the scope analysis phase rather than pure syntax checking. Okay. So check for semantic, exactly. Check for semantic errors. Variables redeclare, and here it says that. It says now the tokenification, and then build the abstract tree here. This is one of the reasons why I am doing this process, is because now with the help of Claude is refine this process. Hosting preparation. Your description is spot on. One important nuance is that let and cons are technically hosted. They exist in the scope from the beginning. Exactly. But they remain uninitialized in the 10 temporal zones. Scope analysis. The phase also determining the scope change will be used during execution, which is crucial. Scope change. The scope change during a scope analysis. And the scope change. And then the scope change here. So functions are stored in memory or hosted. Variables are initialized with undefined. Are hosted and initialized with undefined. Let and cons are hosted. Placed in the temporal dead zone with no values assigned. And the other during the execution. The execution context you mentioned are created with a specific structure. Additional execution context types: model execution context and block execution. There you gotta see. function execution, block execution, create for block scope variables, block execution for let and cons, and the other is the model execution context. Model execution with the French toes, with the French toes, with the French toes. Come on, you die. Okay, what about now? Ooh. Okay. Okay. So JavaScript has two phases when running our code: the compilation phase, the creation phase, and the execution phase. So JavaScript first parse during this phase the syntax analysis, hoisting preparation, and scope analysis, determine which identifier or variable belong to which scope here. Not just import. ES model are loaded and evaluated, not just imported. This happens when the model is first encountered in the dependency graph. Or lexical environment. Or lexical environment. Okay, for let cons. Mm-hmm. And the execution context stack. The JavaScript engine maintains a call stack where these contexts are push or pop. Mm-hmm. And the execution context stack. And the execution context that the JavaScript engine maintains a call stack where these contexts are push and pop. Global context always at the bottom. Function context push when called, pop when finished. Mm-hmm. This happens once per model when it is first imported, regardless how many times it is imported. Mm-hmm. So this happens. Okay. For import and export. This evaluation happens once. Or this execution, the timing depends on the model loading strategy. Each model gets its own execution content with its own scope, which is why models don't pollute the global scope by default. Mm-hmm. The model execution context. Mm-hmm. That's interesting. Mm-hmm. Exactly. Until assignment. Until assignment declaration. Until assignment. Until assignment here. Okay. Mm-hmm. Declaration and implementation. Mm-hmm. Declaration and implementation. Mm-hmm. Mm-hmm. Okay. But this particular process arrow functions behave different from regular functions during hosting. They are treated like variables. So only variables declaration is hosted, not the function implementation. Only variable declarations is hosted, not the function implementation. So only variables are hosted, not its implementation. Okay, makes a lot of sense. So arrow functions assigned to variables are hosted. Exactly. So variables are hosted and initialized with undefined. Variables with arrow functions assigned will be hosted var will be hosted, but not the function implementation. Execution context detail. This execution context has three main components: variable environment, lexical environment, and the this binding. Call stack behavior. The stack follows the first LIFO. Last in, first out. The call stack behavior is last in, first out. And this is the reason why I'm doing all of this refining process, because I want to know, I want to understand, I want to organize and to control what's going on. So semantic analysis also happens during phase. Reference resolutions, type checking, dead code detection. Okay. In the execution phase, context creation involves three main components for each execution context: variable, lexical, where var function declaration live, lexical environment where lexicon live inherit from other scope, and the this binding. Additional execution context, generator execution context for functions, async function execution context, so forth, so on. And the call stack behavior. So it passes this function execution context. A variable environment, a lexical environment, and these bindings are created. A function is called, so for example, generators or async. Exactly. Normal functions, normal generator, and exit. A variable environment, lexical environment, and this binding are created. And the goal is this. Function execution context. An outer reference. Okay, function execution context, which is this, a variable environment. So, variable environment, lexical environment, this binding, and outer environment, reference are created, which is the links to parents scope, which enables closures. Which enables closure, man. Which enables closures here. Oh, come on. Not again. Which enables closures.
According to what the program told it to do. So we have to think about JavaScript, whether you like compiler theory or not, we have to think about JavaScript as a two-pass system rather than a single pass. If you think about it only as a single pass, you end up having to do all sorts of other contortions to avoid incorrect analysis of your programs. And I have seen a number of bugs where people have thought about scope incorrectly. So we want to make sure we dig in and get this. What happens when we process our code, which I will call compilation. If you feel better calling it parsing, doesn't matter. But we're going to process the code first and set up the scopes, and then we're going to execute it. Okay?
Exactly. Process the code first, and then process the code first, and then scope.
We'll call compilation. If you feel better calling it parsing, doesn't matter. But we're going to process the code first and set up the scopes.
Exactly. So the TLDR is that we are processing the scope first. We are processing the curves first in the bindings or the compilation phase or parsing phase and the execution code. Exactly. We're gonna process our code first. We're just gonna process the code first and set up the scope and then execute it.
And then we're going to execute it.
So we can summarize this. So we can summarize this by saying parsing our code and set up the scope.
We're going to process the code first and
Exactly. Process the code first. So process the code first and set up the scopes and then execute our code. Oh, come on, for real? Okay. What, are you receiving some sort of attack? Okay. But not a function implementation. Arrow function don't create their own execution context for this. Arrow function don't create their own execution context for this. They inherit from the enclosing scope. From the enclosing scope. So if you want to double check this, for example, if I say something like this, say comes, let's say, hey, this is now an object, where inside of this object we're gonna have is this, so property here like name, so John Doe, John. And then some functionality here we say so play with this is now an arrow function, and I just want to have access to the console log, which is this. Alright, so anytime that I render this, gonna print that out that, and what I do is this, I'm going to execute that code, which is pointing to which is pointing to the windowed object with the arrow function. Because this is part of the dynamic scope. However, if you say something like this, and then you refresh, that's pretty mind-blowing. That's pretty mind-blowing, bro. That now with the function is pointing to the object itself. It's creating its own bindings of this function. Oh crap. And the arrow function, when points to this, it will point to whatever this was called. That's pretty fucked up. Okay, let's move on here a little bit, shall we?
Set up the scopes, and then we're going to execute it, okay? And I want to understand, or I want to talk about where those buckets come from. So if the identifiers are the marbles, what are the buckets? Well, the buckets are our units of scope. And in JavaScript, we primarily have functions, but we also now have blocks. As of ES6 a few years ago, we have blocks. So you have functions and you have blocks. Those are the units of scope. That's how JavaScript organizes them. Those are our buckets, and we create those whenever we encounter those scopes as we process the code. And then we have the marbles. We create those every time we see a marble being referenced in our program. We create a marble for it and drop it in the appropriate bucket. To understand this a little bit more concretely, I want to walk through a piece of code, which within a few seconds of glancing at, you can, in your mind, have executed and said, oh, I know what this program is going to do. But it turns out there's a lot more complexity to this code than we are typically used to dealing with. And I'm going to try to train you over the next few minutes to think about this code in a way that more closely matches the way the JavaScript engine thinks about it. So we're going to do that by way of what's going to sound like a bit of a silly exercise, but hopefully it'll be lighthearted enough to keep you engaged and interested. We're going to pretend as if a conversation's happening in this processing of the JavaScript program. There's going to be two actors, two entities that are going to be talking. One is the compiler, the thing that's processing the JavaScript program. The other one is the scope manager. And scope manager is the one that makes buckets, makes marbles, drops the marbles in. It's the compiler who says, hey, I have this thing, and it's the scope manager who says, I'm going to make a plan for that. I'm going to make a plan for a bucket and make a plan for a marble. So that'll be our first pass through the program, is that compilation step. And then after we've set up all those plans, then we'll come back and execute the code. So we want to process this code according to that conversation. And you can follow along with me. You can literally speak out loud. It helps you. It's sort of an old teacher trick. If I get you to say this stuff out loud, it embeds it more in your brain. So as we go along, I want you to speak out loud with me, even though it sounds a little bit silly. Remember, in our processing phase, in our compilation phase, we have a scope manager and we have a compiler. So I'll play the part of compiler talking to a scope manager. And when I come across, as I see here on line 1, when I see on line 1 a var declaration, whether it's a let or a const or a var isn't relevant at this moment, but I'm going to use vars just for the simplicity of illustration. That's a formal declaration. In other words, we're creating a marble. And we got to know what color to make that marble, so we got to have some scope that we're adding it to. And in this case, obviously, it's the global scope. Okay? And just for the simplicity of our discussion, I'm going to use the three primary colors. I'm going to say that the outer global scope is going to be the red bucket, and then whenever we have inner buckets, we'll have blue and green. Okay? So we have a red bucket that represents this global scope, and I, being the compiler, whenever I see a formal declaration like I do on line 1, I'm going to say, hey, global scope, hey, red bucket, I have a formal declaration. I have a marble here, Have you ever heard of this thing called teacher? And I'm asking this question because if it already knows about an identifier of the name teacher, it doesn't need to do anything. That's a no-op. There's no such thing as redeclaration. It's just, okay, great, you already know about this marble. But in this particular case, since it's the first time that the compiler would have asked the global scope about a variable called teacher, then the global scope's going to say, nope, never heard of it, but I've created now a red marble for you, and boop, now we just dropped it into the red bucket. It hadn't actually been created. They don't get created for real until execution, but conceptually we're creating this plan from what we see in the program. So yes, global scope says, sure, we'll make a red marble and we'll drop it into the red bucket. Now, what we're doing is looking for these formal declarations, and sometimes they look like on line 1, var teacher. Sometimes they look like line 3, functions or another kind of declaration. Functions make a marble. In this case, the marble on line 3 would be called other class, and that needs to get added to some scope. So if I ran across, as the compiler, line 3, a formal declaration for a function, I would have the same conversation with the scope manager. I'd say, hey, scope manager.
Hey, scope manager.
Compiler here again.
Compiler.
I found another formal declaration, in this case for a marble called other class. Have you ever heard of that identifier before? And in this case, what's my answer going to be?
No.
Nope, never heard of it.
No,
but here's another, what color marble?
Red.
Red marble,
Red.
because we're still in the global scope. So here's another red marble, boop. So now we have 2 red marbles in the red bucket. That takes care of the identifier other class
So
as well as the identifier teacher.
of
Now,
the
I
class.
being the compiler, I'm smart enough to realize, oh, that's a special kind of thing because a function makes scopes. It makes buckets. So hey, scope manager, guess what? We're going to need another bucket. And to stretch this metaphor a little bit, now we're creating a bucket inside of a bucket. So we're like a giant barrel and then a tiny little bucket inside, okay? I know
Like
it's
a
stretching the
Matryoshka.
metaphor a little bit. But now we had a giant red barrel,
Stretching out the
and inside of
mantle.
it, hey, scope manager, we need a blue bucket because it's a function. So scope manager says, sure, now we got a blue bucket. Now we're talking about the blue bucket, and let's step into that function and talk about it as its own scope, since that's functions create scopes. So where's our next
Since
formal
the functions create scope, and again, here we are now creating is this.
declaration then? Well, it's on line 4.
Mm-hmm.
4, right? Line 4 has another formal declaration. In this case,
But again, this, okay, because it's in this phase that it's creating is now the identifiers, the static analysis is parsing our code, as well as the scope setup here. Mm-hmm.
for a variable called teacher. So the conversation is going to continue exactly like before. Even though it's the same name, same conversation. We're going to say, hey, blue bucket, hey, scope manager for this other class.
Scope manager for
I have a
this.
formal declaration for a marble
Class.
called teacher. Ever heard of it? Now, the answer to that question might surprise you because you might think, sure, we heard about it on line 1, but remember, we're talking to an entirely different bucket now. We're talking to the blue
Exactly.
bucket,
We're
not the
talking
red
to
barrel.
a
Okay?
different,
I know this stretches the metaphor
scope
forward
manager.
with them. Okay? We're talking to the blue bucket, so we're saying, hey, blue bucket, do you have a marble called teacher?
Exactly. We're
And
talking
what's
to
blue
a
bucket's response? What's the scope
different
manager going to say?
Nope.
But here's your, what color marble?
Blue
Here's your
marble.
blue marble. Okay? So now there are 2 marbles in 2 separate buckets of 2 different colors, even though they have the same name. Follow me? By the way, having 2 variables at different scopes of the same name, that has a term. It's called shadowing. Sounds like sort of like evil or whatever. There's nothing bad about it. Shadowing is entirely okay. But there is an offshoot of shadowing, which is now that we've created a variable called teacher, we've created a blue marble called teacher in that other class scope, well, now there's no possible way that we can reference lexically the variable from line 1. We can't reference the red marble because now there's a blue marble of the same name because of the shadow. It's totally okay, but it does limit us from what we can access because those names, it would match the nearest one, which in this case would be the blue marble. Follow me? So, we look for any other formal declarations. Do we find any more in the other class
It's
function?
because during the compilation
We see a reference to
phase,
console.log, but we see no more formal declarations,
but we
so
don't
we're
see
finished
any
with the
more
other class
formal
function.
declarations here.
Now we step back out to what color scope?
Red.
The red scope, the global scope. And we look for the next formal declaration. What line do we find the next formal declaration on?
8.
How about
In
line
line
8? You see here the formal
here.
function declaration for an identifier called
Because
ask.
it's
The conversation
walking
continues
through
exactly like
this-
before. The conversation
it's
says,
because it's
hey, what
walking
scope?
through these
Hey,
definitions
global scope, a
here,
red
or
bucket.
these
I have a formal
declarations.
declaration for an identifier called ask. Ever heard of it? And the answer is?
Nope.
Nope, never heard of it, but here is your
Red marble.
red
Red
marble.
market-
Great,
red
following
marble here.
perfectly. There's a red marble because we are in the global
We're in
scope,
the
and that's what
global
color
scope,
marble
and we're
matches with the
putting
red
is
bucket.
all
Yes.
of this
Why did we skip over
definition.
console log?
We didn't skip over it from the perspective of compilation. That is a good question. The compiler would have certainly handled line 5 and done a bunch of compilation. It doesn't have any impact on our scopes. So we've narrowed our focus of compiler theory to preparing our identifiers in our scopes, doing our marble bucket sorting thing. So we're just skipping over the
So just skipping is
uninteresting
all
details
the
at this
und-
point, right? There's whole courses
So
on.
we're just keeping is all of this under interesting topic here about that, because we're focusing on the scope here.
compiler theory that would get into all the nitty-gritty of line 5, but since it doesn't create or access any variables within our scopes, we don't need to worry
So
about
we're
it.
going to get
Make
out
sense?
of this nitty-gritty.
All right, so
details
we
about
just made a red marble called ask, and being a good compiler, we notice, oh, that's attached to a function. Guess what, Scope Manager? We're going to need another bucket. This one we'll call the green bucket. So Scope Manager, could you go ahead and make a green bucket for us? Scope Manager says, sure, and now we step into the scope of the green bucket,
And
the
then we get
function
into the
labeled
scope
ask.
into this.
Okay? So we look for formal declarations in that function. Where do we find the next formal declaration?
The formal declaration.
Line
is a
9. You see there on line
question.
9, I have a var declaration. So this is getting real repetitive. The conversation goes exactly the same way. Hey, green bucket.
scope
Hey, scope of
manager.
ask. I have a formal declaration for an identifier called.
Hey, I'm the compiler. Hey, scope manager of ask. I have a formal declaration of the question or the var question or this identifier questions. Have you ever seen that before?
Question. Ever heard of him? And the answer is.
No.
But
Here's your green marble.
here's your green marble, right? So we get a green marble and boop, we drop it in the green bucket. Now this is critical because you'll
But again,
notice
this
on
is
line
only
10
the
we have a
formal
reference
citation is
to
what
an
we really
identifier.
care about in this
This
scope.
isn't creating marbles, so in this processing step we're not going to worry so much about creating it, but we are going to have to understand where that marble comes from, what color marble that is, when we execute the code in the next step. So it's critical that we do this marble sorting correctly as we process the code the first time. So we're done with the ask function, right? There's no more formal declarations. And then we step back out to the global scope. Do we find any more formal declarations in the global scope? No.
No.
Okay? So thumbs up, we are now done with that processing stage, with that compile.
Declarations here. Declaration, not execution. Okay? Declarations, which is different to execution. Execution is something that produces, that runs, where a declaration is something that says the intention.
Compiler phase of this code. And what we are left with is a plan for all the buckets and all the marbles. We've accounted for all the scopes that exist and where all the identifiers fit into all of those, including references to them, like on line 10. We know what color marble that is. You with me? We know all of that stuff. We've got all that plan all laid out. That is then handed over as part of the execution plan so that the virtual machine, the JavaScript engine, can run this code. Everybody with me? Now, it's important to note that when we execute the code, there's no more declarations for anything. All the vars are gone, essentially, because we don't need to declare anything anymore. We already know what that's going to do because we've figured that stuff out at compile time. So one key takeaway, don't miss this, one key takeaway is that in a lexically scoped language, which JavaScript is, all of the scopes that we're dealing with, all the lexical scopes and identifiers, that's all determined at compile time. It's not determined at runtime. It is used at runtime, but it is determined
So all of these
at compile time.
lexical
And why that matters
declarations
is
are
that
defining
allows
at
the engine to much more
compilation phase.
effectively, much more efficiently
parsing
optimize
time.
because everything is known and it's fixed. Nothing during the runtime can determine that this marble is no longer red, now it's blue. Once we've processed through, we already know what color marble it is, and we're done with that
So once
discussion.
we know
So that allows the
what are
JavaScript
the
engine to be much
variables
more
and
efficient
needs
at its
and
job.
where it
The
belongs
takeaway that you
in
should
the
have from that
scope.
is the decisions that I've made about scope are author time decisions. When I write this function and I put this variable here, it means that that variable is always going to be that color marble. We have all of our plans set up. There's no more declaration code. There is still executable code. So even though line 1 looks like one statement, it's actually two separate things. There's the var teacher part. That's what the compiler handles. And then there's the teacher equals Kyle part. That's what the execution engine is going to
execution.
handle. Okay? Now remember, a little bit ago, I said that there's only two roles that a variable can
That a
play.
variable
It
can
can
play.
either be the target of an assignment, and you can see on line 1 that teacher is in that role. It is receiving an assignment. It is the target.
Is it target?
The only other role that it can play is it is in the source position. It's going to give up its value. You're going to retrieve the value from it. That's like what we see on line 10.
Retrieve.
Question is in that position. So old school terminology for this is, and this isn't what people normally, if you do a Google search on Wikipedia, they won't use these terms, but I learned computer science like more than 2 decades ago, so here's my old school terminology. We used to refer to this as a left-hand side, an LHS, and an RHS, a right-hand side, as in left hand and right hand of an equals. Nowadays, you might call it an L value, an R value, maybe just for simple purposes, let's call them source and target. Here on line 1, teacher is in a target position. On line 10, question is in a source position. You follow that? That's a piece of information that the compiler picked up. Whenever it created that whole abstract tree and all that, it knew that each identifier, each marble, not only what color it was, but what position it was in. And that's critical, and we'll see in a bit why that's so critical. It's critical to know that we're dealing with something that's receiving a value, it's a target, or we're going to retrieve its value. Okay? So let's then execute this code the way the JavaScript engine would with all that execution plan and scope stuff set up. Each time we enter a scope, all of the plans for the buckets and the marbles will have been created, and so now we're ready to go ahead and execute.
So after we parsing our text and then define the scope, so by asking this or by pathing this, by walking through this code and understand now, hey, the conversation between the compiler and the global, the compiler and the context, or the scope context, or the execution, the context, the functions, how do you call it? The context, the scope context, or the scope managers. This conversation between the compiler, whoever, which is are going to create and process our code, and the scope manager, which is going to indicate where all of this declaration live. Okay, that's what the scope is. Where does it live? Okay, where I need to look. Where do I need to look?
We have two people talking again. We still have the scope manager, because he's got to hand out the marbles. But we also now have a different person talking in the conversation, and that's the virtual machine. It's the JavaScript engine that's executing code. So that conversation on line 1, remember there's no var there, it's going to go like this. I'll play the part of the virtual machine of the JavaScript engine. Hey, scope manager, JavaScript engine here. I have a target reference for a variable called teacher. You see, it's a target reference. It's receiving an assignment. Have you ever heard of this marble called teacher? We're talking to the red bucket, remember? Mm-hmm. And it can only answer yes or no. So in this case, what's it going to answer?
Yes.
Yes. Why? Because at compile time, we formally declared it. Okay? Had we not formally declared it, things are different. But because at compile time, we formally declared something called teacher, now we know, yes, here's your red marble. So it's fundamentally a lookup. We're saying, hey, red bucket, do you have a marble called teacher? If so, please give it to me. Okay? And here we get the red marble. Here's your marble.
But here we are talking to the JavaScript engine here.
I'll play the part of the virtual machine of the JavaScript engine. Hey, scope manager.
So the conversation is with the scope manager here. So with the compiler first, and then you switch the conversation to the JavaScript engine on the execution.
JavaScript engine here. I have a target reference for a variable called teacher. You see, it's a target reference. It's receiving an assignment. Have you ever heard of this marble called teacher? We're talking to the red bucket, remember? And it can only answer yes or no. So in this case, what's it going to answer? Yes. Why? Because at compile time, we formally declared it. Okay? Had we not formally declared it, things are different. But because at compile time, we formally declared something called teacher, now we know, yes, here's your red marble. So it's fundamentally a lookup. We're saying, hey, red bucket, do you have a marble called teacher? If so, please give it to me.
Scope manager, do you have
and here we get the red marble. Here's your marble. Okay? Yes. And what are we going to do with that marble? Well, we're going to assign a value to it. That marble represents an area in memory that needs to get assigned to, essentially. So we're going to take the value from the right-hand side, in this case, the string Kyle, and assign it to that location represented by the red marble teacher. Line 3 through 6 and line 8 through 11, those were declarations. They're not there anymore, in a sense. They've been compiled away. So execution would move to line 13. Let's talk about how line 13 executes. Okay? Don't skip just to how the function itself, how it runs inside. We first have to ask how the line 13 itself executes, because JavaScript has got to figure out that and execute it. So is the other class identifier, the thing that we see there at the function call, is it in a target position or is it in a source position?
Target position.
It is, in this case, is in the... I'm not sure about the definition of the target of that. Can you please elaborate
that there's only two roles that a variable can play. It can either be the target of an assignment, and you can see on line 1 that teacher is in that role. It is receiving an assignment.
Is the roles of variables. It can be either in a target position, so it's receiving something.
Variable can play. It can either be the target of an assignment, and you can see on line 1 that teacher is in that role. It is receiving an assignment. It is the target. The only other role that it can play is it is in the source position. It's going to receive, give up its value. You're going to retrieve the value. That's like what we see on line 10. Question is
whether it is you're assigning, you're the target of this assignment, or you are retrieving that value.
In that position. So old school terminology for this is, and this isn't what people normally, if you do a Google search on Wikipedia, they won't use these terms, but I learned computer science like more than 2 decades ago, so here's my old school terminology. We used to refer to this as a left-hand side, an LHS, and an RHS, a right-hand side, as in left hand and right hand of an equals. Nowadays, you might call it an L value, an R value, maybe just for simple purposes, let's call them source and target.
Side of the equation.
Here on line 1, teacher is in a target position. On line 10, question is in a source position. You follow that? That's a piece of information that the compiler picked up. Whenever it created that whole abstract tree and all that, it knew that each identifier, each marble, not only what color it was, but what position it was in. And that's critical, and we'll see in a bit why that's so critical. It's critical to know that we're dealing with something that's receiving a value, it's a target, or we're going to retrieve its value. Okay? So let's then execute this code the way the JavaScript engine would, with all that execution plan and scope stuff set up. Each time we enter a scope, all of the plans for the buckets and the marbles will have been created, and so now we're ready to go ahead and execute. We have two people talking again. We still have the scope manager, because he's got to hand out the marbles.
Exactly.
But we also now have a different person talking in the conversation, and that's the virtual machine. It's the JavaScript engine that's executing code. So that conversation on line 1, remember there's no var there, it's going to go like this. I'll play the part of the virtual machine of the JavaScript engine. Hey, scope manager. JavaScript engine here. I have a target reference for a variable called teacher. You see, it's a target reference. It's receiving an assignment. Have you ever heard of this marble called teacher? We're talking to the red bucket, remember? So and it can only answer yes or no. So in this case, what's it going to answer? Yes. Why? Because at compile time, we formally declared it. Okay? Had we not formally declared it, things are different. But because at compile time, we formally declared something called teacher, now we know, yes, here's your red marble. So it's fundamentally a lookup. We're saying, hey, red bucket, do you have a marble called teacher? If so, please give it to me. Okay? And here we get the red marble. Here's your marble. Okay? And what are we going to do with that marble? Well, we're going to assign a value to it. That marble represents an area in memory that needs to get assigned to, essentially. So we're going to take the value from the right-hand side, in this case, the string Kyle, and assign it to that location represented by the red marble teacher. Line 3 through 6 and line 8 through 11, those were declarations. They're not there anymore, in a sense. They've been compiled away. So execution would move to line 13. Let's talk about how line 13 executes. Okay? Don't skip just to how the function itself, how it runs inside. We first have to ask how the line 13 itself executes, because JavaScript has got to figure out that and execute it. So is the other class identifier, the thing that we see there at the function call, is it in a target position or is it in a source position?
Target position.
And in this case,
is the other class identifier, the thing that we see there at the function call, is it in a target position or is it in a source position?
In a source
Target
position.
I'm hearing some targets. Anybody disagree with that?
Line 13, right?
Line 13. Is other class in a target position or in a source
It's
position?
a source position.
Okay? It's in a source position. We're not
Because you're
assigning
gonna
something to other class, so if we're not assigning to it, what must we be doing?
The point of view is from the assignment here. The point of view is from the assignment here. The point of view from the assignment here. And the sources and the source and the target. Hey, are you the target of this assignment or you are the source of this assignment? In this case, this assignment is you're going to retrieve that value or you're going to assign a value. Okay? Left hand side or right hand side. Okay, here we are now combining three concepts, especially during the declaration or the compilation phase. That is now analyzed is the formal declarations as well as the scope. And then at runtime, which is what we're doing, is now going to talk about with the scope managers and put it the value or assigning or retrieving the value.
Pulling a value out. We want to know what is currently in the identifier other class. Because in just a moment, we're about to try to execute it, right? So we need to go get it. So what are we going to do? We're going to do the same thing as before. We're going to say, hey, global scope, hey, red barrel, if you will. I've got a source reference for a marble called other class. Have you ever heard of that marble? And what's the answer going to be? Yes. That's a good thing. I've got a source reference for a marble called other class. Have you ever heard of that marble? And what's the answer going to be?
Yes.
Yes. That's a good thing, because we need a marble. If we're asking for it, we're going to need it. So he gives us the marble, and what do? We pull the value out from that location in memory conceptually. We pull the value out. What is that value at this moment?
This whatever is in the scope, in this case, other class.
It's the function that other class was declared to point at, right? At compile time, other class, the identifier, was associated with that function. That value is there, that reference, that value is there. So that's a good thing, because then on line 13, those parentheses that we see there on line 13, they execute the thing that we just pulled out of that variable. If we pulled out of that variable something that wasn't a function, like null or undefined, what do you think would happen? Variable. If we pulled out of that variable something that wasn't a function, like null or undefined, what do you think would happen?
Everything would burn.
Everything would burn, that's right, the whole program crashes down. Specifically, what would happen is an error called a type error. Because we would have a value like null or undefined, but that is not a value that is legal to execute as a function. So we're doing something illegal with that type. That's called a type error, a runtime error, or we're doing something with a value that's not allowed for that type. Thankfully, in this case, we got a function, so we can execute it, which means execution moves to what line?
4.
Line 4. Line 4 does not have a var on it anymore, but it does have what kind of operation?
And a target operation.
It has an assignment, so it's got what kind of reference to a marble in it?
A receiving one.
A target, exactly, a receiving one, a target. So that conversation is going to continue exactly like it did on line 1. Hey, scope of other class, hey, blue bucket. I have a target reference
Hey,
for
Scott,
a
manager
marble
of
called
other class.
teacher. Ever heard of it? And the answer is?
Have you ever heard of this
Here's your
formal
marble.
declaration?
So now we have a location in memory. That's a different place
Yes,
than the one
I
from line 1.
have. So
It's a
let's
different
go
location in
assign
memory
it.
because it's a different scope. We have this marble, and then we take the value Susie and we assign into it. And line 4 is executing. Everybody good so far? Now what's going to happen with line 5? We're going to gloss over a bit of this detail, but is there a reference to an identifier on line 5?
No.
Not one that we created, but there is an
No, we
identifier
created
nonetheless,
marble.
right? There is a marble here in a conceptual sense, which is called console.
Which is called
That's got to exist somewhere. The JavaScript engine has that available to us as sort of like an auto global. Not something we created, but it's available nonetheless.
this is
So the same process lookup would happen. We would
is
basically say,
something
hey, scope
you
of
have.
other class, have you ever heard of a marble called console? Because that's in the source position. Now, has other class ever defined a marble called console? So what's going to happen then, and this is the key to understanding lexical scope, is that if we cannot find a variable that is referenced within this scope, that was declared within this scope, what do we do next? We go up one level. In this case, to the global scope, and we would say, hey, global scope, have you ever heard of an identifier called console? And even though we didn't formally declare it, it's an auto global. It's already there. There's already a red marble called console. So what is global scope going to do?
Reference.
Here's your red marble. And we can look on that marble. It's an object. It has a method called log, and so on. So then we can invoke it. Everybody with me on that, okay? When you reference a variable in a source position, you have to first look it up. And when you reference a variable in a target position, you have to first look it up. That's the key takeaway here, is that there is a lookup process involved. So far, our lookups have always found the thing that we were looking for. After a while, we'll talk about what happens when we don't find it, right? But right now, we're all on the good path. We're finding everything that we're looking for.
A question about the function. When the compilation is happening, the function other class gets
So
its
because he's
contents
describing is the
in the marble.
compilation and the
I'm not sure I'm
running
following.
from
So
the
when other
scope
classes being
perspective. Because of
compiled,
what we matter
There's
here in this
like a plan,
conversation.
like a roadmap made up by the compiler to say, for that blue bucket, you need to create an identifier called teacher.
Okay.
Yeah, that's what compiler outputs. It's basically a plan for that scope.
So when does the targeting part happen?
That's at runtime, which is the stage we're in now. At runtime, when that other class function is pulled from some variable, like it is on line 13, and it's executed, well, now we know there's a whole plan to make this blue bucket. So let's go first make the whole blue bucket with all the marbles. And now we're in it, and we're running it. And when we run across line 4, there's a marble called teacher in the target position. So we discover the source versus target position at compile time, but we don't use that information until runtime. Does that help?
Yep.
So it creates a placeholder, essentially.
Yeah, basically at compile teacher in the target position, all the marbles. And now
So
we're in
we
it,
are
and we're running
looking
it.
at
And when we
all
run
the
across line 4,
identifiers
there's a
and
marble
the
called
scope
teacher in the target
at
position.
compile file
So we
phase.
discover the source versus target position at compile time, but we don't use that information until runtime. Does that help?
Yep.
So it creates a placeholder, essentially.
Yeah, basically think of it like a treasure map, right? There's a map, there's a plan, it's like a to-do list
Is it
for
we're
every
creating now
scope.
a
That's what compiler
threshold
outputs.
that
That's
for-
the executable code. And then when it
It's
runs
a
is when
map
it all actually
for
comes
all
into
his
existence.
placeholders.
And
For
one more,
For all
one
the
question, like
identifiers.
when we enter the scope of that function, like I mean, if you enter multiple times, there's like another process that like resets the values and things. How does that work? You know what I'm saying?
Every time you execute a function, the environment is recreated from scratch.
Okay, so what does that actually? Is like in compiler? I don't know.
So remember, the compiler only makes a plan for the bucket. It says, hey, whenever you need a green bucket, this is what the green bucket ought to look like, and this is what its contents ought to
compiler
be.
is
But it
only
doesn't actually
like
exist
a-
yet. And then every time you execute the green bucket, that plan is effected into memory. And then when the green bucket finishes, that plan, all that stuff goes away. And then the next time you run it, creates it from the plan again.
And this
Okay?
is part
So
of
the
the
compiler
core
output is
stack.
not actually reserved memory. It's the plan for how to reserve memory and make marbles and all that.
Is a plan for how you make.
We have
marbles
finished
in
executing
scope.
line 5, and execution moves back. Now we're on line 14. How does line 14 execute? Hopefully at this point, you're feeling a little more confident with this conversation. So how does line 14 execute?
It's gonna now from the runtime perspective, all right? From the runtime perspective, they say, hey, JavaScript, global scope, JavaScript engine here. Have you ever heard about this identifier called ask?
All right, so
All right.
who's talking? It's going to be the virtual machine, the JavaScript engine. And what did he find on line 14? What do we have right here on line 14?
Source.
We have a source reference. Thank you. We have a source reference for a marble called
Ask.
ask. So who are we going to look that up with? We're going to say, hey,
Red.
hey, red scope,
Hey,
hey, global
red
scope.
scope,
Thank you.
global scope.
I have an identifier of a
manager.
marble called
Ask.
ask. Thank you. Do you know about a marble called ask? And the response from the global scope is going to be?
Yes.
Yes.
Here's your red marble. So now we go to that red marble, that location in memory, and we say, hey, red marble, what do you have in it? And what does he have?
Question.
The function, right? He has the function,
the
the
function.
green bucket, the thing that was declared on line 8. So now we have a function, and on line 14, that little open close parenthesis executes the function.
Executes it.
Now execution moves to line 9. Line 9,
So
there's no
we
more
now
var,
have a function
but we're getting to the end now,
context
so how do we execute line
here,
9?
Where anytime that we create a function execution context, it has now a lexical scope and the variable, the execution code, this binding, as well as the outer function, okay? That this outer function property is important because it will create now the reference to the parent scope, therefore allowing us to create now closures, allowing us to organize our code in JavaScript and also use the model pattern for that. So because of that, we need to understand is the scope, so we can understand now closures, so we can now understand is the model pattern.
How's the conversation start?
Hey, green bucket.
Hey, green bucket. Hey, scope of ask. I have a what kind of reference?
Receiving.
This is a target reference,
It's
right?
like a
Receiving
green
is fine
up
too. I have a
function
receiving or a target
execution
reference for an
context
identifier
here.
called
Question.
Exactly, create now an execution context here because now we are at runtime. It say, hey, now that I have this question, now that I have all of these identifiers, all right? Then I'm gonna say, hey, we have
Question.
now this
Right there on line 9.
assignment.
So I have this marble. Ever heard of it? And the answer from that scope is going to be
Yes.
Here's your mark.
here's your green marble. Okay. So now we have the green marble, and we are assigning to it. So we don't care what's in it right now. We go and get the value from the right-hand side. We assign into that location of memory, and line 9 is finished. Now, line 10. We remember how the console works, right? So console doesn't find it there. It goes to the global scope, finds it, finds a method called log. But before it can execute log, it's got to figure out what's being passed to it, right? You see there on line 10 that we're passing something into it. And what are we passing?
So we're passing is now this reference. So you say, hey, do we have now in this function execution context is this identifier called console? No, we don't have. So let me look upward to the scope change. Interesting, which is on the global scope that you have that, or unless the function execution context create that. I don't think so because this is part of the global scope. All right. So therefore, what it's doing is to look up to the scope change, and then now ask, hey, global execution context, do you have now this identifier called console? And say, yes, I do. All right, let's go to now access through the log methods and execute
There's a reference
that
to another marble.
with this parameter.
We got to look that up. So how's that lookup work?
Green.
Hey, green bucket. Hey, scope of ask. I have a what kind of reference? Source reference. Thank you.
Exactly.
For
Question.
question. Ever heard of it? And the answer is?
Yeah.
Yes.
Here's your green marble. And now, because we're not assigning to it, now we want the value that's currently in it. So we go to that area of memory. Ever heard of it? And the answer is?
Yeah.
So the first thing that happen is the evaluation here. Hey, do we have now this question here? Hey, function execution scope. Do we have now this question identifier? Yes, here it is. Okay, and now let me ask for the console here.
Yes.
Here's your green marble. And now, because we're not assigning to it, now we want the value that's currently in it. So we go to that area of memory, we pull the value out, which happens to be the string y in this case, and that argument is assigned to the parameter that console log is receiving. Okay? So arguments, the things that we pass in, get assigned to the parameters that receive them. You can think about a parameter, like if I had function ask and it took a parameter, the parameter is what kind of reference?
It's like a variable name.
It is, but what kind of reference is it? And it's that position.
Is the assignment.
Target.
Target.
It's a target. And if you have a variable in an argument position like line 10, what kind of reference is that?
If you have a
It's a source. So there's a processing and execution of a JavaScript engine aligning yourselves to think about 2 stages of processing. One stage where we figure out all the scopes, all the buckets, all the marbles, and the second
once
stage where we use all that information
the
to execute the
identifiers.
code. Congratulations,
and
I
the scope.
certify you as compiler engineers. You have compiled and run a JavaScript program. So let's just make sure we're all on the same page here. We recall that JavaScript is not a interpreted language in that it goes step by step, one line at a time, but rather we should think about JavaScript as a two-pass processing. First pass, we could call compilation or parsing if we feel better about that, but we're going to go through the entire code, and there's lots of things that happen during the parsing and compilation, but the main thing that happens is all of the scopes, all of those colored marble buckets, the plan for those all get created. We figure out where all the scope boundaries are, and indeed all of the identifier references, those are color-coded as marbles. So we'll have a red marble or a blue marble or a green marble, and we'll use that information about the color of the marble and what bucket it comes from. That information is critical and useful in the second pass when we execute code. So we're going to run through the conversation as our review, and I'm going to hope that all of you are participating with it rather than me only being the one speaking. So follow along with me as we do this. If you're watching on the live stream, talk out loud to your computer, even if that feels silly. Again, it's the teacher trick that if you physically say this with your mouth, it will help you to remember these things. So we'll go through this conversation. Again, the first pass compilation, second pass execution. In the compilation phase, remember, it's the compiler and the scope manager, or the parser, or whatever you want to think of, and the scope manager. They're going to be talking. So we'll play the part of that parser or compiler, and we'll arrive at something like line 1, and we'll say, as compiler, we'll say, hey, scope manager, we're talking to the global scope now, and we'll say, hey, scope manager, I have a formal declaration for a variable called teacher, right? And have you ever heard of that before? So we're talking to the red bucket. We'll say, have you ever heard of it before? If we'd seen var teacher a couple of times in the same scope, the reason for that question is we don't need to make multiple marbles with the same name. It only needs to be created once for the same scope, and there really is no such thing as recreating it, okay? So that question would be, have you ever heard of this identifier called teacher? And the response would be?
No.
No, but I've created, what a color marble?
Red marble.
Red marble. Boop,
And
drop it in the red
identifier
bucket,
here.
okay? Now we find a next
If I
formal
next
declaration, line
one,
3.
which
Hey,
is a
global scope, I have a
declaration.
formal declaration for
Other
other class. Ever heard of it? And the answer is
You have a
No.
formal
Never heard of it,
declaration
but
the
here's
other
your
class here.
red marble.
No?
Boop, we
All
drop it
right.
in the red
Just
bucket.
going to now
Oh, by
add
the
that
way,
to-
global scope, that red marble, that was pointing at a function, so we need a new bucket. We need a bucket inside of a bucket. Can you make us a blue bucket? Sure. Okay, now let's talk about the blue bucket. So we step inside of the blue bucket, we move to line 4, we find another formal declaration.
Oh, because at the compilation phase, all right, because at the compilation phase is evaluating these identifiers in the scope of this identifier. So we're
Hey,
getting
scope
to
of other
this-
class. Hey, blue
Okay.
bucket scope. I have a formal declaration
So
for
we
teacher. Ever
get
heard of it? And the
into
answer
this-
is?
Nope.
Why?
Okay.
Why haven't we heard of teacher?
It's a new bucket.
Because we're talking to a different
Because
bucket.
it's a new
right?
bucket.
And it's important to keep that in mind because when we get to processing, we will ask other scopes. But here we're only considering,
Exactly, it's like
since
you
it's a
get
formal
into the
declaration,
scope.
we're only asking, has it been created for
Like
this
you gotta
particular
get
scope?
into the scope.
The answer is no, but here's your what
Okay.
color marble?
Function
Blue marble,
scope.
okay?
Lexical
Now it's in the blue
scope.
bucket. We don't see any more formal declarations in that function, so we step back out to the global
Lexical
scope,
scope.
the red bucket. The next formal declaration we find is on line 8. Hey, global scope, I have a formal declaration for an identifier called ask. Ever heard of it? And the answer is
No.
But here's your
Red.
red
We have now
marble.
that-
Great, we dropped the red marble in the red
We
bucket.
have not on the
Oh, by the
global
way,
scope.
global scope, that
No?
identifier is pointing
Alright.
at a new function,
Hey,
so we
this
need a
goes
new
into
bucket.
a
Let's make this one
function
green. And
function.
the global scope says, sure, here's a green
Or
bucket.
to a block. It can be to a function or to a block. Okay? In our case, it's just a function.
Now we're going to step into that function and deal with the green
Now
bucket.
we're gonna stay
Hey,
here
green bucket,
as
hey,
a-
scope of ask. I have a
we're gonna
formal
create
declaration
now
for
a scope
Question.
question.
for this.
Ever heard of it? And the answer is?
No.
But here's your
Have you
green
ever
marble.
heard about this?
Green marble goes in the green bucket.
identifier?
No more formal declarations in that
This
function. We step back
formal
out to the global scope.
declarations for
No more formal
question.
declarations in the global scope, and we're done
Okay.
processing. Now let's process this code. Let's execute the code. Remember, all the plan
Now
for all
that
the
we
scopes
have
and everything
processed
is
this,
already
let's
done.
go
We don't
to
have any
execute
declarations
the
anymore. We
code.
just have executable code. Line 1 is going to execute, and we know that
So we
teacher
know
is
that
in what kind of
teacher
position?
is an identifier that we
What
already
position is
saw.
teacher in?
Receiving.
It's either a source or it's a
Target.
target. It's in a target
It's
position
in a
here.
target
So we're going to say
position
we are now
that receives
the
as a-
execution engine,
assigned.
the VM, whatever you want to call it. We're going to execute this code. We're going to say, hey, scope manager, hey, global scope, I have a target reference for teacher. Ever heard of it? And the answer is?
I have a
Yes.
target
Yes, because
reference
there's one
for
in the scope.
teacher.
So here's your
Red marble.
Hey,
red
have
marble.
you ever
Thank you very
heard
much.
about
I go to the
this?
right-hand side, I find the value, I assign it in the
So you're
target,
gonna assign the
and we're done with
value
line 1. Now execution is going to move to
Now
line 13
execution
because
will
remember all the
go
declarations have been
because
compiled
we
away.
have all the
We still see them there for
declarations
symbolic
will go
reasons, but they're not really there like that, right? This is only executable code. So execution moves to line 13. How does line 13 itself execute? Hey, global scope, I have a, what kind of reference?
I have a reference.
I have a source
of
reference.
the
It's
source
right down here
reference of
at the bottom. I have a
other
source
class.
reference. Why is it a source
Have
reference?
you saw this reference, other class?
The best answer is because it's not a target reference. If it's not receiving a target, it must be a source because that's the only two options. So we clearly see it's not receiving a target. It's not the target receiving something, so it must be a source. So, hey, global scope, I have a source reference for other class. Ever heard of it? And the answer is?
Yes.
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 Here's your Red marble. We go and look what's in that red
So
marble.
when I look at what
Conceptually,
is
what's in that
the
area of
green
memory?
marble,
And
when
what
I
is
look at what
that
is
red marble
in
holding right
this
now?
function.
A reference
We're gonna
to
create
that
now a
function which we call other
function
class, right?
execution
It's the
scope.
blue bucket, if you will. Exactly.
All right.
So now we're going to execute that,
Where
which is what
we
the
already
parentheses
have
do,
the
the end
scope
of that line.
defined
Execute the function
at the
that we found.
compilation
We hadn't
phase,
found a function,
and
we would have
what
gotten
we're
a
gonna
what
do
kind of
now
error?
is the
Anybody remember?
assignment or the
A
source.
type error. Reference errors will be different. We'll get to those in just a little bit, okay? All right, so we are executing the other class function. Execution moves to line 4. Hey,
So execution
what
moves
scope?
to the line
Blue scope.
4.
Hey, scope of other class. I have a what kind of reference?
So I have a forward
I have a target reference for.
Have
Ever heard of it? And the answer is?
Yes.
Here's
of course,
your
I'm going to now
blue
assign
marble.
this.
Great. So now we have a blue
to
marble. We go to
that.
the right-hand side. We find the string Susie. We assign it, and we're done with line 4. Line 5, we have a what kind of reference?
We have a source.
The source
A source reference for
Global scope.
for global
Console.
not
Console.
for the
source reference for console. Hey, scope of
Blue bucket.
blue bucket. Hey, scope of other class.
Hey,
Have you ever heard of
global.
console? And the answer is
Oh.
no. So where do we go next?
So we're gonna
We go up one level, which in this case is the global. And we ask the same question. Hey, global scope, I have a source reference for console. Ever heard of it? And the answer is?
Yes.
Yes.
Even though we didn't declare it, the JavaScript environment has provided it to us. So in effect, it's there. Whether it's in the scope or not, in effect, it's available to us. So the response that we get is, yes, here's your red marble, essentially. Maybe it's a pink marble, but here's your red marble, okay? And then we can access a method, a property on the object, and so on and so forth. And then we can execute the function, okay? Now, execution's finished with line 13. We move to line 14. 14 executes exactly like 13. Hey, global scope, I have a what kind of reference? Source reference for. Ever heard of it? And the answer is? Here's your
Green marble.
Red marble.
red marble.
So,
Remember, we're
hey, exactly. So we go to evaluate this. Hey, have you ever seen about this as before? Exactly. Hey, have you ever seen about this identifier? The answer is yes. This is a execution. This is exactly. This is an execution. Hey, have you seen about this identifier? Yes. Good. Let's go to access to that. Let's go to now execute that. Create a function execution scope. What we already know is the scope of these declarations. In this case, the question. Okay. And let's go to now assign that in the target position. So we're going to assign this value to the questions. Let's going to evaluate is the next one, or in other words, we're going to say is, hey, function execution here. Have you ever heard about this formal declaration called questions? It's identifier. Yes. All right. Let's go to assign this value to this. Okay. Good. Now, next one. Hey, have you ever heard about this identifier called question? Yes, here's the value. All right, let's go into now pull the value and assign that to the first parameters here on the console log. Question, do we have now console log in this scope? Function execution? No, we don't have. So let's go to look up to the outer reference, or to the outer for that, to check if we have now that on the global scope. Yes, we have, of course, because this is part of the global scope.
in the global scope now. So we're talking about an identifier in that scope, a red marble, okay? All right, so now we have the red marble. What's being held in that location of memory?
Red marble says go to green bucket.
It does, well,
No?
that particular marble is referencing the function, which has the green scope attached to it, but here's the function reference, right? Functions have a scope, but they aren't a scope. Okay, so here's the function reference. We execute it, which is going to end up invoking, as you were saying, the green scope. So now we're in the green bucket. We move execution to line 9. How does line 9 execute? Hey, scope of green bucket. Hey, scope
Exactly. Hey, scope of ask. In this case, it's a function execution. Hey, scope of ask. Have you ever heard about this declarations here?
of ask. I have a what kind of reference?
Target.
Target reference for question. Ever
So
heard of it? And the
target
answer
reference.
is?
Yes.
Yeah, I have. Okay, so let me now actually assign this value to this.
Yes. Here's your
Because this is the
Green
green
that
marble.
can happen
We
to
take
a
the
variable.
string y on the right-hand
Either
side,
or
assign it,
access to
and
the
now line
variable
9 is done.
as a source,
Finally, line
or
10,
do
we
you
look
either
up console.
assign to, which
We don't find it
becomes
in the scope of
target
ask. Where do we find it? So red marble, right? We find it in the global scope, exactly like we did from line 5. But before we can call that log method on the console object, what do we have to do first?
Get the source of the question.
We've got to figure out what that is. So that question is going to be, hey, scope of
Green bucket.
green bucket, hey, scope of ask. I have a what kind of reference?
Source.
Source reference for question. Ever heard of it? And the answer is?
Yes.
Yes. Here's your
Green marble.
green marble. And what is in the green marble at that moment?
Y.
The string, quote, y. And because it's an argument, what are we going to do with that argument? We're going to pass that argument into that function, which has the effect of assigning that argument to a parameter. So the final step here, which we don't see that function, but the final step would have been that function saying, hey, I have a parameter that's receiving this assignment. I need to look up that marble and then receive the assignment. Everybody with me? Same process. Even though we don't see the equal sign there, conceptually the same thing's happening. An argument's assigned to a parameter. Okay, line 10 is done, line 14 is done, and our program is complete. Okay, so hopefully we're feeling pretty good about lexical scope, but let's test some of the little edges and corner cases that exist within this. Let's make sure our understanding is fully working. So we're going to process this exactly the same way as we did on the previous slide, which is that we want to first do the...
And this is part of the edge cases here. Edge cases here. Edge cases here. Makes a lot of sense. All right, so that'll be all for this video. Take care. Bye-bye.